right. So, that is merge. Now, let us look at an example for merge sort. This is my sequence, right. As you can see, it is not sorted, 8 element sequence. So, the first step is a divide step. We will divide this into 2 parts, right. So, one part is this, okay, and the other part is this. This is the division, right. And I have shown it lower down because I am kind of doing a recursive call of merge sort. So, this corresponds to like one level of recursive call, right. So, first I do a merge sort here, this is another merge sort call, then I will do another merge sort call here and so on. So, this is a recursive call on this part of the sequence, on these 4 elements, right. And how is this done? This is done by once again dividing this into 2 parts. 8524 is one part and the other is the other part, and I do a recursive call on this part now first. First I do the division, then I do a recursive call on the first half, then I do a recursive call on the second half, right. तो अभी तक कुछ भी नहीं हुआ है, we just seem to be doing divisions and doing recursive calls, as you can see, right. And how do I sort this part? Once again I divide it into 2 parts, 85 and 24, and I do a recursive call on 85, just a single element sequence. And what is the solution for this when there is only a single element? That is itself a sorted sequence. So, 85 goes back. So to say, we go back to the previous, to the parent calling procedure, right. So, that is 85. So, this is the sorted first half, and this goes down and this is also sorted. So, this is the sorted this, and now we have to do the merge at this call, right. So, we have to merge this sorted sequence which is just 85 sitting in this blue oval, and the other sequence sitting in this blue oval are the 2 sorted sequences. We have to merge them, right. So, right now we will just do the merge. So, the resulting, as you can imagine, is one sorted, okay, this is the resulting merge sequence 2485, and this is one sorted sequence. So, now we have finished the merge sort for this call that we had done 8524. So, now this can go back up, right. We have finished that merge sort, yeah, and now we are going ready to do the merge sort on the second half. Everyone follows what I am doing here, right. Let me show you the procedure once again. First we divide, then we merge sort the left half, and then we merge sort the right half, right. And when I am merge sorting the left half, what happens? I once again divide, and then I merge sort the left half, and then I merge sort the right half, and when I am merge sorting the left half, what do? I once again divide, and so on and on, right. So, in some sense, you know, so I divide, as you can see, I divide here, I divide into 2, merge, first do a merge sort on this, and nothing is to be done here so far. And then how do I do this? Once again I divide, and then I do merge sort on these 2, but first I do it here. Only when I am finished with this merge sort will I come back to this one. And how am I doing a merge sort here? Once again I am dividing, this is the trivial case, so this is easy to do, this is the trivial case, so this is easy to do, and I get this sorted sequence, right. So, I have finished the merge sort for this part now, so this goes back. Now, I have to do the merge sort for this part. So, once again I am doing a recursive call on this, I do a call, divide, trivial, merge 4563, yeah, and now this is my sorted sequence. So, I am now ready to go up, and this is now the 2 sorted sequences that I get, and now I can merge this. So, I will show you the merge step again more clearly, but you can see which should be the first element, it should be 24, right. So, this is what I will get, the sorted the merge sequence, and now I have done with this part. So, this merge sort call has finished, the merge sort call that I made on these 4 elements, that has finished. So, it goes back up, right, and now I will do a merge sort call on this, right. So, I do one merge sort call here. So, I am not showing you the entire thing, I am just showing you that this entire thing would happen in exactly the same way. 1731 96 50 would sort, and you will get 1731 50 96, this goes back up, and then we will merge these 2, right, and this is the resulting sequence you will get. So, these are 2 sorted sequences, we can merge them. I will show you how to merge them very quickly, and that will give us the resulting sequence. So, who can tell me how many merge sort calls have I made in all? Log n, 2 log n, How can you count the number of merge sort calls you have made? In this example, how many merge sort calls have I made? N. N minus 1 actually. Order n. Right? Why? Because each of these blocks corresponds to one merge sort call. पहले हमने इसके ऊपर merge sort call किया तो इसने दो में divide किया, एक यहाँ पे और एक यहाँ पे आया. इसको हमने merge sort किया, इस पे merge sort call किया तो वो दो में divide हुआ, वो एक यहाँ आया, एक यहाँ. इस पे call किया दो, वो दो में divide हुआ, एक यहाँ यहाँ. इस पे call किया तो कुछ नहीं हुआ, वो वापस number उसी तरह से return हो गया. So the number of merge sort calls is just the number of nodes in this tree. And how many nodes are there in this tree? Well, you can see that this is the tree. How many leaves are there in this tree? N leaves, right? There are n leaves, so at this level there will be n by 2 elements, at the next level there will be n by 4, n by 8 and so on and on. Sum of this sequence n by 2, n by 4, n by 8, n by 16 so on is n minus 1. You can check that. Yeah, there are many other ways of thinking of it. You can think of it as a complete binary tree on n leaves and you can apply those formulas that you learnt. Okay? So this will do exactly n minus 1 recursive calls. Yeah, to merge sort. So everyone follows what's happening? Great. So let's see the part that we missed out on. How do we merge two sequences? Right? Two sorted sequences, I should really say two sorted sequences. So let's say these are two sorted sequences I have S1, S2, 24, 45, 63, 85, 17, 31, 50, 96. Right? So these are, I believe, coming from 24, 45, 64, 85. Are they the same? No, they are not the same, slightly different. Okay. So these are the two sorted sequences. We have to merge them. Right. So what should be clear is that the first element of the resulting sorted sequence is the smaller of these two. Right. So it's clear that the resulting sorted sequence, which is S, has as its first element 17. Right. And then I can strike away 17 from here, because I have kind of removed it and I have put it here. And so now I have to just merge these two sequences. Yeah, I have to merge these two sequences and append them to this sequence that I am constructing. Yeah. So how do I merge these two sequences now? Once again the same idea, which is the smallest element, which is the next element, will be the smallest element in these two sequences put together, and that will be one of these two. Right. So the next element should be 24, right, and so I remove 24 out of there and I get two smaller sequences like this. Once again I have to find out the smaller of these 6 elements, that has to be the smaller of these two. So I will just compare these two and I will write that down here. So I compared, I found 31 is smaller, I write that down here and I remove 31 from this. Yeah, and in this manner I can proceed. So 31, 45 would be the next one to go. These are the things left, then the next one would be 50, we would be left with 63, 85, 96. Then the next one would be 63, and then we would be left with 85, 96, next would be 85, left with 96, and eventually we would be taking that and we would have nothing left, right. So this was, so this is what you would get as a result. So how much time do we take in doing the order n? Why? Is this clear to everyone that we are going to be taking order n time? Right? Because what are we doing? We have these two sorted sequences. We are comparing two elements, the two, right, the two front elements. We are comparing them and taking the smaller of those two and writing them out into one, into the resulting sorted sequence, right. So with every comparison we are writing out one element. How many elements do we write out in all? As many elements as there are there, right. So if there are n elements, then I am going to be writing out n elements in all. So which means how many comparisons am I making? N comparisons, exactly n comparisons actually, right. This was assuming that the two sequences were of length n by 2 and n by 2. Suppose one sequence was of length L and the other sequence was of length M. right. So, I had one sorted sequence of length L elements and the other sorted sequence with M elements in it, S1, S2. What is the total time taken by merge? L? L plus M, M, L, what should it be? Minimum of, so these are the 4 choices you have, right? And let us see. Minimum of L comma M, max of L comma M, और क्या? L plus M. कोई और बचता है? None of the above, ठीक है? None of the above. Which do you think is the right one? Min? बताइए मुझे वर्स्ट केस कितना होगा? बेस्ट केस कितना होगा? वर्स्ट केस कितना होगा? Okay, let's look at worst case. Who can tell me what's worst case? Let's look at worst case. What is worst case? Okay, in the worst case, what do we have to do? We have to in the worst case we will have to compare no, actually, right. So, worst case should be L plus M, right? We might have to do every possible comparison. Best case, what is the best case in your opinion? Huh? Okay, please. So, best case, it's not really clear what I'm trying to say by best case, right? Because what might happen is that if one of the sequences finishes, right, then I can just copy the next one. So, in the even the copying requires time, right. So, if you include the time for the copying, then it's always going to be L plus M. You cannot do anything more about it. But if you don't want to include the time for the copying, if you are just counting the number of comparisons that you do, then if you are just counting the number of comparisons, then you can do less. Then it will be. ठीक है? So this is what. Okay, so you all understand this. If you have. So in the worst case, why do you require L plus M comparisons? So you might require as many as L plus M comparisons, right? So in fact, that was happening in this example, where till the very end. Not necessarily, right? So if you count the number of comparisons that we did in this example, so for every element that we had to write out, we had to do a comparison, right, except for the last one. So you really required L plus M minus 1 comparisons, right, and that was the worst case. The number of comparisons, if you are counting the number of comparisons, so you really require that many, right, and you can create sequences of arbitrarily values of L and M, so that you require L plus M minus 1 comparisons. Okay, good. So we have understood merge, right, we have understood the merge step, we understood what merge sort